All right. Hello, everyone. Long time no see. Happy New Year. So today we're going to be covering the center of mass. This comes right after. This is during Unit 2. This is mostly having to do with motion, forces, and dynamics. So let's get started. So in your formula sheet, it will be referred to as something similar to this. X center of mass equals to sigma. Sorry, I have a hard time drawing this symbol. Like that. And then you have the mass of the first object, and along with its location, or distance, or position, really. That's kind of what x represents. But it can also be referred to as d1. Not to be confused with anything else. And then you have mass. The addition of the masses. Yeah. So this is not to be confused, but basically what this means is the addition of all masses times their positions, relative, of course. And then this is addition of all masses. So do not cancel these out. These cannot be just canceled out like that, all right? Actually, I feel like it would be much easier if I had something like this. There we go. So yeah, so these two, the m's, cannot just cancel out. So yeah, don't get that confused. That's nice. The laser pointer. So important note is that this can pop up in collisions, and you'll know about that later on in the later units. So just put a little note there. This can pop up in collisions. So you'll learn about non-elastic, perfectly conservative, and non-conservative. This can also be referred to as like that. That's just another way of saying it. Center of mass. Keep in mind these are kind of vectors, so because they have the position relative to something. So yeah, same thing. Obviously, same formula. So if you do the well, let's say you wanted to calculate yeah. So let's say you wanted to derive this equation, right? So you know what momentum is, right? Momentum of a system. This could just be m1 v1 plus m2 v2 plus m3 v3 ... Okay, I can go on forever, right? Now, obviously, what you don't know, or what we're learning here, is that the momentum of a system can actually be broken down into two things. Just like mass and velocity, it can be broken into VCM. So what this stands for is the central mass, velocity of the center of mass. That's what I mean. Velocity of center of mass. This is a very niche kind of topic. You'll not be using this a lot. This is kind of like the most important one right here. Obviously, they have the same formula, but they mean different things. But just if you want to know how to derive it, or you can further understand the actual physics behind it, this would break down into the mass of the system, of course, because we know momentum is the velocity, and then you have the velocity of the center of mass. And then you can just rewrite the equation, blah, 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 like this, dot, dot, dot. And now you can get that VCM equals M1 V1 plus M2 V2 plus M3 V3, dot, 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 all divided by the mass of the system. Now, what do we know about this? It's actually the addition of all the masses. So this is the addition of all the masses. And then this is the addition, sorry, I don't know, there we go, of all the masses times their velocities. So yeah, there you go. That's how you derive it, the actual equation. Keep in mind, yeah, this technically is for the velocity, but it kind of really means the center of mass. So yeah, there you go. There's also another factor. So obviously there's center of mass, there's the velocity center of mass. So what comes after that? Obviously the acceleration center of mass. Good job. So this is another thing you're probably never going to use, but it's important to know, or I wouldn't really say important to know, but it's useful to know. A lot of times they'll throw in some trick questions or whatever. So that would be the acceleration center of mass. Sorry, I'm just thirsty. Let's keep going. So to derive this, it would be, so what does F equal to? F equals MA. So what does the F net equal? Well, M1 times MA1. And maybe you can already see where I'm going with this. So try pausing the video at any time and do it on your own. So then what can we break down into F? M of the system times the A of the center of mass, because it's a system. And the acceleration has to be kind of like an average. Think of the center of mass like an average, basically. That's technically what we're doing. And later on, we're going to do some problems so you can really further understand that and what it means, you know. M2A2 and M3A3. Now you can see that the acceleration or the center of mass, as you can see, same as all the other things, it ends up being an addition of the mass times the whatever center of mass we're looking for, divided by the masses. So what you can kind of like derive from this basically is that you can find kind of the center of mass of any single type of, I don't want to say force, but kind of like variable in some sense. But you're not going to be doing that at this stage, but you can kind of see how you can apply it to many things. So that's basically it for that. And then just one very little extra step that we have to add and learn is the actual Newton's law of gravity. Now, I can't remember if I've already covered this, or you probably already have covered it. But it's just the actual way of writing the law of gravity. So usually we can just say Fg equals mg. But this is the actual gravitational force, and we can see by using capital G and small g. One's a simplification, and this is the real one. So we have a g, which is the constant gravitational force, times the mass of an object, times the mass of the other object. So this is between two objects, obviously, because gravity is between two objects. And then you have the radius between those two objects squared. And very important note, this is something that will catch you in physics, is that they love dealing with proportionality. This is something I struggled with, but actually it's quite easy for other people. It's really easy to understand, but it's kind of hard to discover by your own, to be honest. It's kind of like, I don't know. For me, I don't get it. So proportionality, you have, let's say you have A and let's have B. So for A, you have 2 times the mass, then the radius stays constant. And for B, you have normal mass, but then the r gets 2 times. So for the FG, what would it equal for A and B? Okay, well, let's figure it out. So FG equals G times 2m1, 2m2. So basically, all these are constants. And then you have the r. So we have constant, constant. Technically, these two masses will become one. So you have G2m, because that's what's been referred to as here. So G2m. So we have a constant, constant, constant. And so what we can figure out with this is by being in the numerator is that the Fg will equal to 2 times the normal Fg, nu. So times 2. But what happens if we multiply the radius by 2? Well, we have Fg times Gm. And remember the r squared. I completely forgot about that. Sorry. Then you have the 2r squared. So that's it being the G, the M, and then the 4r. Yeah. So this would be actually 1 over 4 Fg. Now, I feel like the very much easiest way, in my opinion, to do it is to replace all constants with the number 1. So let's take this for example. We know that G is a constant, so we make it a 1. M is a constant. What's changing here? What's the R? But the R is a constant, but we're timesing by 2. So we have 2 times 1 squared. That's not really true, is it? Because what's going on here is that the 2 times 1, that kind of happens first, and it's kind of difficult to deal with this, but just treat it as the R is becoming 2 in this case, because you're multiplying by 2 squared. And that's kind of the factor you're going with. If it was decreasing by a factor of, I don't know, 25%, decreasing by, it would be 3 over 4 squared. So just deal with it as it's given to you. And then this will give you 4 times. Therefore, Fg nu will be 1 over 4, so 1/4 of the old G, gravitational force. So that's a very quick review on the Newton's law of gravity. And you'll have to kind of deal with this when you have a center of mass, because the center of mass that kind of determines what the force of gravity is on an object. So let's just say, for example, I did a project in this. You're jumping a high bar, and the reason your body, or in this case, Olympian athletes, will do this banana curve is so the rest of the mass is distributed below, lower, and relative to the floor. And so what this will do is lower their center of mass, because more of the mass is closer to the floor. And this has to do with the, not exactly the gravitational force, but the potential gravitational energy. So due to that, you'll have a less of it, and more will be able to be just less kinetic energy will be needed to require that height. That has to do with kind of Newton's law of gravity and the center of mass. So let's just do some quick problem reviews. So let's say that a 5 kilogram mass is placed at the origin. And then a 9 kilogram mass is placed at x equals 2 centimeters. Perfect. Where or what is the center of mass? The center of mass. In this case, it's where, because we're asking for the location relative to the origin. So, as always in physics, let's draw it out. So we have the origin here, then 2 centimeters, let's say around here, 2 centimeters. So we have a 5 kg, and then a 9 kg. So what was the equation for the center of mass? Well, it was, you can just state down the axis first. So x equals 0 centimeters here, and then x2 equals 2 centimeters. To make it easier, let's turn these into meters. So x2 equals 2 meters, and then 0 meters. So for the center of mass, it was the addition of all masses times their position divided by the addition of all masses. So then we expand this. Oops, sorry about that. We can just expand this into m1 x1 plus m2 x2. And then we can do m1 plus m2. See how they don't cancel out? Makes sense, right? So now we can further expand. Oops, gotta fix that. That looks weird. So the mass of the first object is 5 kilograms, and its position relative to the origin is 0 meters. Then we have 9 kilograms, and then 2 meters. Now, the reason I just made it meters is so it's easier. If we deal with centimeters, sorry, we just have to divide by 100, so it'd be 0.02. Whatever. It's just easier that way, yeah? And then we have 9 kilograms and times 2. And then we have 5 plus 9. So, my calculator, I don't have it, but I know that it's 0 plus 18 divided by 14. So, the position of the center of mass for these two objects would be, I think it should be around 1.3. Something like that. Let's see. 18 divided by 14. 1.29. So 1.29 meters. So that would just be the center of mass for these two objects. So really, it's quite simple there. Now let's deal with another one here. So this one kind of takes it a bit on its tail. How long are we going at? 20 minutes, perfect. So let's say a 8 kilogram mass is placed at y equals 3 meters. So here we just deal with the y. It just means vertical position instead of a horizontal. Nothing to worry about. Now, for this one, we're going to ask, where should a 10 kilogram mass be placed at? So where should a 10 kilogram mass be placed at? Along the y-axis, of course. Gotta specify. So that the center of mass will be located at y equals 4.5 meters. Okay, so this one, it's not too crazy. It's just algebra here, but we can just state what we know. So first, we will draw it out. We can draw it lower here because we're just dealing with the y-axis. So we have an 8 kilogram at 3 meters. 8 kilogram, y equals 3 meters. And then we want the center of mass. Oops. Sorry, I just realized the center of mass is actually higher than the object. So let's put it here. Y equals 3 meters. Y equals 4.5 meters. So this is the desired spot for the center of mass. And this is our current object at 3 meters, 8 kilogram mass. So what we want to aim for is that the x cm equals to 4.5 meters. Y-axis, of course. Now we can just substitute. What does the equation equal? As we know, m1x1, and then m1, m1, moshi moshi. So we have the first mass, which would be, well, first we can just expand it. Let's name this 1, and then the mysterious 2. So we have, how much is it? 8 kilograms. First, it's always useful to leave it in, what is it called? Variable form. So you don't have to deal with numbers messing around. Because you can just cancel stuff and simplify. It's much easier that way. x2 divided by m1 plus m2. Here we go. So now we can finally just start plugging in. So we have 4.5 meters, but we don't have to deal with that. I already forgot 8 kilograms. Yeah. 8 kilograms at 3 meters plus an unknown. Oh, sorry. M2 is actually known. M2 equals 10 kilograms. M1 equals. I was starting to think I made it unsolvable because I saw 2 barrels. I was like, what? There's no way you can solve that. And then x1 equals 3 meters. So x2 is kind of what we're looking for here. So we have 10x2. Then we have 8 plus 10. So 4.5 equals, we have 24 plus 10 x2 divided by 18. And here we can just do 4. Yeah, we can do 4.5 times 18, 81. So we can get rid of the denominator, 24 plus 10x2. And then we can do 81 minus 24, and then divide that by 10. And that's how we'll get the position of the second object. So the position of the second object should be around minus 34 divided by 10 should be around 5.7 meters along the y-axis. So as you can see, it's just a deal of substituting around and finding the placement. Now in a center of mass, you won't always be dealing with just 2 masses, but just apply the same kind of formula and just make sure you actually stabilize which one is the unknown. So I'm just trying to find a good problem on my book. Let's see. Okay, let's do this one. This will be The last one for last, and it's not too much of a long video. So last problem. Let's say a 10-meter long 4,000 kilogram truck. What does it say? Has its center of mass 4 meters behind the front of the truck. Alright. So we're just to imagine a truck. We can have like this. Alright. And then we have 4 meters. Actually, no, it would be near the front. So like this. So it would be 4 meters here. Center mass. So that's just kind of how we imagine it. It's always important to kind of imagine these things. And then we are asked, where should we place a 1,400 or 1,400 kilogram load so that the center of mass be right in the middle of the truck. So what we mean by that is the middle of the truck. So how long is this truck? 10 meters. So in the middle, it would be 5 meters. So first, as always, let's state what we know. So we know that the truck, well, in this case, technically, we just want to state down the equation because we don't really know what these things are referring to. Obviously, I know that's going to be center of mass for this, but we don't exactly know that. So we can just refer to, it would be easier to actually just draw a diagram out. So here we go, boom. These things have wheels actually. So one there, and then you have the truck compartment, like something like that. That's good enough, whatever. Anyways, so we want to know where we should place this big old 1,400 kilogram object, because right now the center of mass is at 4 meters, but the desired center of mass, desired, is at 5 meters, so right in the middle. So around here, 5 meters. I'm just gonna say that right here, 4 meters. So that's not actually directly in the middle, around here. So that's the desired center of mass. So what do we know here? Well, let's state down the formula. In this case, we know it's going to be center of mass because it says in the question. So we can state down the formula first, and then we can state the variables. So it would be sigma of the masses times their positions times the addition of all the masses. Okay. So then this will be into the mass of the truck times its position plus the second mass times its position. So this would be x2 and so then we just divided by m1 plus m2. So we have x cm equals that. So now we can actually start subbing in the variables. So the desired one we want is 5. And the one we currently have for the truck. So first, what's the mass of the truck? Well, we know that, actually, it'd be easy to just state that, what we know. So XCM desired is 5 meters. M1 of the truck is 4,000 kilograms. Its position, aka like the center of mass, so if it currently has, would be 4 meters. The second mass is 1,400 or 1,400 kilograms. And its position, well, we don't know where to place it. So let's now rewrite the equation. 4,000 times 4 plus 1,400 times x2. Then we divide it by 4,000 plus 1,400. There we go. So now we have to do is add those together. So 4,000 plus 1,400 equals 5,500, and then multiply that by 5. We have 27,000. Then we have 4,000 times 4, which is 16,000. There we go. So we can do 27 minus 16. So we have 11,000 equals, I was going to divide there, but we can do it step by step. Then finally we can just divide. 1,400, 1,400. So 11,003 divided by 1,400 would be around 7.86 meters. Boom. So, what can we actually state? That we would have to place it around here. I hope the drawing there and give it away from the start. So make a little statement. We will have to place the M2 1,400 kilogram. I'm just used to using variables, so that's why. At 7.86 meters behind the truck for its center of mass to be exactly at, I wouldn't say at, in the middle of the truck. Middle of the truck. There we go. So congratulations, good job. So sometimes you won't be given numbers, and let's just say this whole thing, actually let me do this with here so I don't mess anything up. Sometimes you'll be given just the length, and so in this case you can probably already figure out, but if we want to know the center of mass exactly in the middle of the truck, we'll just have to do L divided by 2. So these are the kind of things that if you're currently taking AP Physics or just physics and you have to deal with only variables and no numbers, you kind of have to kind of just think about it slowly and not to rush too much. Obviously in the test you will have to rush, but just practice, make perfect, and yeah, I really hope this can help you. So let's just do a quick review here. So the center of mass is the addition of all the masses times the position relative to the object divided by the addition of all masses. This will and can pop up in collisions. There's also the velocity center of mass. That's how you derive it from momentum. And then the acceleration center of mass, which is just F equals ma. Those are not important. Newton's law of gravity is pretty important. So you just have the gravitational constant times the two masses. So in this case, a lot of the time when you'll be using this, it's like, let's say you have a planet and then you have a object surrounding it. So you'll be timing their mass together times g, and then the radius will be this. So this is kind of where you use like circular math, like this, and then you have the radius. And so as you can see, obviously it resembles kind of like an arc. Yeah, well, don't worry about it. And then proportionality, good tip, just replace all the constants with ones, and then whatever you're changing, just replace it with the number you're changing. So in this case, r, so you can do it this way, actually rewrite the equation, or you can do it with the ones. And since r is being times by 2, the r, we replace it with a 2, and so you end up with constant 1 1, so 1/4. So then the new fg will equal a quarter of the old fg. So, and then these questions are just to state down like kind of like normal center of mass questions you'll have to deal with. Obviously they'll be much more complicated, but this is a good one as well. Kind of a more realistic scenario. Sometimes they'll also give you more than 3, like I mentioned. So let's say you have these 4 in a corner, and then you have to find like the center of mass around there. But at the end of the day, these are just locations, and you can just do that, right? And then mass of the system. So you just add all their masses, then the locations. In this case, it could be something like, I don't know, X and Y. It could just be something like that, or it could just be X position, Y position, Z position, anything like that. So I wish you all a happy new year. Hopefully you meet your resolutions, and yeah, good luck in physics. Much love. Thank you. Thank you for watching.